morning, students. Today we are going to discuss a very important topic, and this topic is continuous charge distribution. This topic is very much important for studying the application part of the Gauss theorem, which will be your next topic. So, what is continuous charge distribution? Now students, whenever we deal with a large amount of charge, we neglect the concept of the quantization of electric charge. Now what is this quantization of electric charge? You have already studied this in your previous lectures. So I am just recalling this. What is quantization of electric charge? This quantization of electric charge states that the charge on an object is equal to integer multiple of the quanta of the charge. Quanta of the charge means E. E means 1.6 into 10 raised to the power minus 19 coulomb. So whenever we deal with a large amount of charge, we neglect this quantization of electric charge. We assume that the charge is distributed uniformly over the object. Now this concept that whenever a charge is distributed continuously over an object, this is known as continuous charge distribution. This continuous charge distribution can be of three types. Number one dimensional charge distribution. Number two, two-dimensional charge distribution. Number three-dimensional charge distribution. Now, one by one, we will discuss all these continuous charge distribution. So, first is one-dimensional charge distribution. Now, what is this? Now, if the charge is distributed along a one dimension, then it is known as one-dimensional charge distribution. Now, what is the meaning of one-dimensional? It means, suppose this is your coordinate axis. This is your origin. This is x-axis. This is y-axis, and this is z-axis. So, in one-dimensional charge distribution, charge is distributed either along x-axis, along y-axis, or along the z-axis. So this one-dimensional charge distribution, it is also known as linear charge distribution. Linear charge distribution. For example, let us consider a very thin wire, and the charge is distributed over the length of this wire. Then this is known as linear charge distribution. Right? You can see here that suppose this is a wire AB, and the charge plus charge, it may be negative charge. Right? This charge is distributed along the length of the wire. Then this is known as one-dimensional charge distribution. Now, with this one-dimensional charge distribution, a quantity is associated. A physical quantity is associated, and this quantity, it is known as linear charge density. Linear charge density. Now, this linear charge density, it is represented by lambda. इसको हम किससे represent करते हैं? Lambda से represent करते हैं. Now the definition of this linear charge density is, this linear charge density is defined as the charge per unit length of the wire. सपोज एक वायर है, जैसे ये वायर आपने लिया है और इस वायर पर सपोज आपने अज्यूम कर लिया कि क्यू चार्ज जो है वो इसकी लेंथ जो है एल इस पर डिस्ट्रीब्यूट है, इस पर डिस्ट्रीब्यूट है. So then according to the definition of linear charge density, this is linear charge density is equal to charge upon length, right? So here charge is q and length is l. So this linear charge density lambda is equal to q upon l, q upon l. Now this is the mathematical expression for this linear charge density. Now from this definition you can determine the unit of this linear charge density as we know that the unit of charge is coulomb and the unit of length is meter. So its unit will be coulomb per meter, right? Now the dimensional formula for this linear charge density, you can easily determine this, that this coulomb lambda is equal to क्या है आपके पास में c coulomb upon length. We know that the dimension of charge जो है c is at, right, and the dimension of length is l. So its dimensional formula will be at L minus 1, right? This is the dimensional formula for the linear charge density. Now let us consider one example. Suppose you are having a ring of radius capital R. ये आपके पास में एक रिंग है, इसकी रेडियस है कैपिटल R, and suppose a charge plus q is distributed over its circumference. जो इसकी circumference है उस पर चार्ज आपने अज्यूम कर लिया कि भाई q जो है वो इस पर डिस्ट्रीब्यूट है. Then the linear charge density for this ring will be lambda is equal to q. Q is the charge which is distributed over its circumference upon length. And what is length? Length is the circumference of the ring. So it means it is 2 pi r, right? So the linear charge density for this ring will be q upon 2 pi r, right? So moving to the next continuous charge distribution, it is two-dimensional charge distribution. Two-dimensional charge distribution. Now if the charge is distributed along two dimensions, then it is known as two-dimensional charge distribution, right? Two-dimensional charge distribution में suppose again consider this three-dimensional coordinate system. This is the origin and this is x-axis, y-axis and z-axis. Now in two-dimensional charge distribution, the charge is distributed along two dimensions. For example, let us consider this plane x and y. Now here the charge is distributed along this plane. So this is two-dimensional charge distribution. You can consider this y and z if the charge is distributed along yz plane, right? And in the same way you can consider this xz plane. Now here the charge is distributed as this. So if the charge is distributed along a plane or along a surface, then this is known as two-dimensional charge distribution, right? Now this two-dimensional charge distribution, it is also known as surface charge distribution, right? Means charge is distributed along the surface of the object, then this is known as surface charge distribution or two-dimensional charge distribution. Now with this two-dimensional charge distribution, a quantity is associated which is known as surface charge density. Right? What is it? This is surface charge density. As we already defined the linear charge density, we can define the surface charge density as the charge distributed per unit area of the object. कोई भी आपके पास में एक सरफेस है, उस सरफेस के पर यूनिट एरिया में कितना चार्ज डिस्ट्रीब्यूट है, दैट क्वांटिटी इज नोन एज surface charge density. Now this surface charge density, it is represented by sigma. इसको हम किससे represent करते हैं? Sigma से. So its mathematical expression will be sigma is equal to Q upon A. Now where Q is the charge distributed over the entire surface of the object and A is its complete area. Right? So here the surface charge density for this object will be sigma is equal to Q upon A. Right? Now from this mathematical expression you can determine what will be its unit. You can see here that the unit of Q yani charge is coulomb and unit of area is meter square. So its unit will be coulomb per meter square. Right? You can easily calculate the dimensions of this surface charge density is as means you can write down it coulomb, it is 80 and meter square means L raised to the power 2. So its dimensional formula will be A T L minus 2. Right? So this is the dimensional formula for the surface charge density. Now you can consider one example. Right? Let us consider a solid sphere. Right? A solid sphere of radius capital R. This is a sphere. Right? This is not a ring, but this is a sphere. Sphere of radius R. And suppose that charge Q is distributed over its surface. Right? इसकी जो surface है, उस surface पर charge कितना distribute है? Q. Then according to the definition of surface charge density, here sigma is equal to क्या होगा आपके पास में? Q upon the area, surface area of the sphere. तो सरफेस एरिया कितना होता है एक स्फीयर का जिसकी रेडियस r है? दिस इज 4 पाई r स्क्वायर. राइट? सो दिस इज द surface charge density for the solid sphere. Sigma is equal to Q upon 4 pi r square, where Q is the charge over its surface and r is the radius of this sphere. Right, students? Okay. Now coming to the next continuous charge distribution is three-dimensional charge distribution. Now what is this three-dimensional charge distribution? Now you can easily understand this if the charge is distributed along three dimensions. Along three dimensions means x-axis, y-axis and z-axis. Then this is known as three-dimensional charge distribution. Now three-dimensional charge distribution, as we know that in three-dimensional charge distribution, the charge is distributed over the complete volume, right? Because volume consists of L, B and H. It consists of all the dimensions. So here we can say this three-dimensional charge distribution, it is also known as volume charge distribution. Now if the charge is distributed over the complete volume of the object, then this is known as three-dimensional charge distribution or volume charge distribution. Now with this volume charge distribution, a quantity is associated, and this quantity is known as volume charge density. Volume charge density. This volume charge density, how it is defined? It is defined as charge distributed per unit volume of an object. अगर आपके पास में कोई भी एक ऑब्जेक्ट है और उसके यूनिट वॉल्यूम में कितना चार्ज है, तो दैट amount of charge it is known as volume charge density. So what will be its definition, or you can say the mathematical formula for this? This is equal to Q, volume charge density is equal to charge upon volume. This volume charge density, it is represented by a notation rho. This is rho. So its mathematical formula will be rho is equal to Q upon V. So this is its mathematical formula. Now from this mathematical formula, you can define its unit, and this is coulomb per meter cube, right? Now in the same way, you can write down its dimensional formula as, here you can change this as 3, so this will become MAL minus 3. So this is the dimensional formula for the volume charge density, right? You can consider an example. Let us consider a sphere of radius r. Here charge q is distributed over its complete volume, right? Here the situation is changing. Here the charge is distributed continuously over its volume. So its volume charge density means rho. It is defined as charge q upon, now the volume of the sphere. What is the volume of the sphere? This is 4 by 3 pi r cube. So this is what? This is volume charge density for the solid sphere of radius r, where q is the charge distributed over its complete volume, right? So student, this topic is one of the most important topic for the study of the application of Gauss theorem, which will be your next topic. Okay students, in the next topic I will complete another important topic. This is Gauss theorem. So please attend this class regularly. Thank you.